Hi everyone and welcome to my channel. I go by name is B and today I'm gonna go through 2017 exam questions 4, 5 and maybe 6 if it's not gonna make long video. So let's start with question 4. So we have graph f of x 4x over x plus 1, so this one here. So on the same graph we have the slope of the chord, it's shown, and it does represent the average rate of change of f of x for the interval from x equal to 0 and x equal to 4. So this point here is going to be 0, 0, 0. So I'm just going to go back here. My pen is not doing what's it's supposed to do. So 0, 0. And find the slope of the chord. Maybe you have seen this before. M represents slope, differences in y over differences in x's. Maybe you're more familiar with y2 take away y1 over x2 take away x1. So, and then equal to, pretty much what you do, you just choose, you use the point, so we use this one here. So y coordinate for that one is 16 over 5. Take away y coordinate for this point here is 0 over 4. Take away 0, which is, this point here. Oh, looks like face. Just gonna make it happy face then. Okay, so equal to, and if you do simplify this, you're gonna end up with 4 over 5 or 0.8. So the next one, it's about interpret the value of f dash of 4. So you do have to say f dash 4 is the instantaneous rate of change of the function when x is equal to 4. So you have to mention that it's instantaneous rate of change of that function when x is equal to 4, or you may say the slope of the tangent when x is equal to of the slope of the tangent to f of x when x is equal to 4, or at x equal to 4. Okay, next one, back. So on this graph here, so we have to draw the slope that is closer to approximation of the slope of this chord. So if we do pick any point here and then connect, so this is the better approximation. So it could be, any line here. You only need one line. Now we're gonna have a look at part C, where we have to look at the slope of the chord that approximates the value of f dash of x. On the graph, draw a chord that has a slope that more closely approximates the value of f dash of 4. So we have to go, but what do you need to pay attention to is sometimes those questions here are hidden. So, and sometimes kids forget to do it because it's, as I said, like sort of hidden there. So now the next one is using the first principle to find f dash of 4 for the same function, and there are 2-3 different ways of finding it. I'm gonna use this method, finding f dash of x when limit x is approaching 4, and then I'm gonna have function of f of x take away f of a over x take away a. In our case, a is equal to 4, so if you want, you can find f of a on the side, so which means we're using this function here, okay, and all we're gonna do is, instead of a, instead of x, we're gonna have the value of a. This is gonna be a plus 1. So a is 4, that's 4 times 4, and 4 plus 1 equal to 16 over 5. So you can do that on the side, or you can just substitute straight away in this part. So equal to, make sure to have equal and limit written every time, and as well the x is approaching 4. Now what we're going to do, instead of f of x, we're going to use the original function. So it's 4x over x plus 1, take away f of a, we have already calculated, so we're gonna replace this by 16 over 5, then x take away a, and the value of a is given, it's 4. Now next line, tidy up a little bit. So what I would do, I would be looking for the same denominator for x plus 1 and 5, and that should be easy. Pretty much is just, we multiply those two. So, and we do cross multiplication here, so like that. So in numerator here, we're gonna have 5 times 4x take away 16, x plus 1. Okay, hopefully you can see that, and then still over x take away 4. Now equal to limit x approach 4, and we do have double fraction, so pretty much if I add here like divided by 1, it's double fraction. Again, I don't know how you have learned to simplify double fraction. I find that kids think it's easier if we do something called inside outside. So pretty much we multiply the outside parts of the double fraction and then inside. So, and the outside one goes above the line, so it goes in numerator. So because we have just one here, not much will change. Pretty much we can just copy what we have in the numerator, and the denominator now is going to have 5x plus 1 times x take away 4. Okay, let's have a look if we can now simplify, cancel out something, see. So what's going to happen? 4 times 5x is 20x. Take away, let's expand this like this. Okay, let's expand that. It's going to be negative 16x. That's not a pen. Now negative 6 times plus 1, it's negative 6. And if you want, you can expand the denominator, but there is no need, because we do need something in the numerator that is the same as x take away 4, so that we can cancel out. Because if I replace x approaching 4, if I take this 4 and replace it x, is going to give me 0. And we all know that we can't have 0 in denominator. So therefore we need something in numerator so that we can cancel out this x take away 4. Okay, copy that one, x plus 1. I'm hoping you like the colors. Okay, equal. Let's go back to black. Limit x is approaching 4. Now looking at this one here, we can simplify. 20x take away 16x, that is 4x take away 16 over, just copy this, and now you know that you are looking for something in the numerator, so that something that looks like x take away 4. So if you take 4, like factorization, you're going to be left with x take away 4. Beautiful. so x take away 4. Now what we can do, x take away 4, x take away 4, so that is gone. And the next step it will be, as x is approaching 4, now we're gonna substitute this, so we don't need limit anymore, so it's gonna have 4 over 5. Instead of x we have 4 plus 1, so that's gonna be simplified to 4 over 25, and that would be it. And actually I will stop here, so it's only going to be one question that's recorded here, and that's question 4. So I'm going to have different video for question 5 and 6. Thank you. Bye.